And we are going to finish this up with the second part of Unit 5, talking about a kite. So, like it's kind of, alluded to here, we're not talking about this type of kite. We're talking about this type of kite, where a kite is a quadrilateral, again, four-sided figure that has two pairs of consecutive congruent sides. So consecutive means next to, it's almost like adjacent. And then congruent means the same. So we can see that right here and right here. They're next to each other and the same. And right here, two lines that are next to each other, consecutive and congruent. So there are kind of two properties of kites. One is that their diagonals create a 90-degree angle. So let's write that down. Diagonal (90-degree). Let's say that the diagonal meets at 90 degrees. So that's right there. And then the opposite angles are congruent. Okay, so we have opposite angles are congruent. So let's put those to good use. Let's test them out. So again, thinking about our whole quadrilateral family, if we go back to, I believe it was this one right here, we've now filled it in. These are trapezoids, and these are kites. And so we have, under quadrilaterals, we have trapezoids, parallelograms, and kites. Rectangles and parallelograms, or rectangles and rhombuses are parallelograms. Sometimes a rhombus can be a kite, but not always. And a rectangle and a rhombus, when they have equal sides and equal angles, create a square. So we know that it's a kite. WXYZ is a kite. Find WX. So again, if I just mark up what I know, this side is congruent to this side. This side is congruent to this side. So I see, again, pull out what you know. I see that we have a triangle, and I know, because of the property, that this is a 90-degree angle. Perfect. This is 7 and this is 15. So I'm going to use the Pythagorean theorem of 7 squared plus 15 squared. And I'm just going to call this x. Doesn't matter. 49 plus 225 is 274, which means that WX equals the square root of 274. And so just to get an approximation of that, that's about 16.553 approximately, which would make sense because it's got to be bigger than 15 and 7. Find YZ. So let's take a look. If we want to try to find YZ, all right, I might have to use some different knowledge. I know that this is a 14 degrees and this is a 7. So again, what should you do? You should draw the triangle, pull it out. I have a side of 7. I have a degree of 14. And then this is what I'm trying to solve. So if I label from my reference angle, opposite, here's my right angle, so this is hypotenuse, and this is adjacent. I know that using SOHCAHTOA, I want to use the opposite and hypotenuse, which would be sine. So I'm going to solve this by saying the sine of 14 degrees equals 7 over x. If I multiply by x on both sides, and then I divide by sine, and I divide by sine, again, that cancels out. I really have x equals sine 7 over sine 14. Again, if that doesn't make sense, we cancel out here, we canceled out here. What we really did is we flip-flopped sine and x so that we can type this into our calculators. 7 divided by sine 14. And we get 28.93. Let's round that to a 5. So YZ equals 29 or 28.935. There's kites.